Welcome to the F5 Networks Advanced Web Application Firewall Demo and Exercise Series. In this exercise, we'll explain how entity enforcement affects whether the BIG-IP Advanced WAF security policy allows or blocks illegal requests. This is an exercise which represents Demo 17 of the AWAF demo series, and it's intended for intermediate-level BIG-IP Advanced WAF users. For optimal viewing, we recommend using full screen mode. The environment for this exercise contains 3 devices. A Windows workstation will be used for sending requests to build the security policy. These requests will arrive at the F5 BIG-IP system, running Advanced WAF. The BIG-IP system sits in front of the backend web application. The BIG-IP system, using its full proxy architecture, examines every request before sending them to the backend web server. Through this process, BIG-IP Advanced WAF can begin creating a web application security policy. The security policy is used to protect the web application. Now, when a user submits malicious requests, BIG-IP Advanced WAF can fully inspect every request and can block all malicious requests and prevent them from going to the back-end web servers. We'll start by accessing the DVWA web application and attempting to access confidential web server files. First, we'll try to access the php.ini file. We are successful. Next, we'll try to access the readme.md file. Not only are we successful, but we've accessed a file with important and confidential information about the database server, such as the administrator username and password. We can copy this password and then attempt to log in as the administrator. We are successful. You can see at the bottom of the page that we logged in as the user ID admin. These are examples of forceful browsing attacks, which exploit web page files that are not accessible through web page links, but are in fact present within the web server directory. Now, let's protect the web application. First, we'll take a look at the virtual server we were just using to access the DVWA site. This is a standard HTTP virtual server that listens on 10.1.10.35. We'll now create a BIG-IP Advanced WAF security policy to protect the virtual server. We'll give the policy a name. Select the template type, which for this policy we'll leave set to fundamental, and select the virtual server we're protecting. In addition, we'll specify the web application language. Finally, we'll add a trusted IP address range for building the security policy. We'll next access the Learning and Blocking Settings page. We'll expand File Types and change the Learn New File Types option to Always. We'll then expand Parameters and change the Learn New Parameters option to Never, Wildcard Only. We'll learn about parameters later in this exercise. We'll then save. And apply the policy. Now, we'll access the web application from a trusted workstation to generate requests for building the security policy. Next, We'll examine the allowed file types page. 8 explicit file types have been added to the allowed file types list. The different file types are called entities in BIG-IP Advanced WAF. We'll delete the wildcard entry to prevent the security policy from allowing any file types that are not on this list. We'll now return to the Learning and Blocking Settings page and stop the learning of new file types. We'll now open the security policy, which we can quickly get to by clicking on Application Security. Now that we have our full list of file types, we can disable policy building to prevent learning any new file types. Don't forget to save and apply the security policy. We'll now use the web application and attempt to access confidential files again. First, we'll attempt to access the php.ini file. The request is now blocked by the BIG-IP Advanced WAF security policy. We'll also try to get the confidential database details from the readme.md file. This request is also blocked by Advanced WAF. The web application is now protected against forceful browsing attacks. Let's examine these blocked requests in the BIG-IP Advanced WAF event log. First, we'll filter the log files to view only blocked log entries. The first request was blocked for several reasons. The INI file type is illegal because it's not on the allowed file types page. This request was blocked for the same reasons as the previous request. Both forceful browsing requests were blocked because they were for file types that were not added to the allowed file types list. Now that the security policy has a file type whitelist, and the security policy is in blocking mode, any requests for file type entities that are not on the whitelist will be blocked by BIG-IP Advanced WAF. Next, we'll exploit the attributes of a specific file type. Let's examine the allowed file types page. The 4 different length values are attributes of each entity. Each of the file type entities are in staging, which means that BIG-IP Advanced WAF will not enforce their length limit values. For the rest of this exercise, we'll focus on the PHP file type entity. We'll update 2 length attributes. We'll change the HTTP request length limit to 3,500 bytes and the query string length limit to 800 bytes. Then update the file type. You can now see the PHP file type with its new length limit values. We'll now apply the policy. In the web application, we'll submit an extremely long query string for the index.php page. This request is allowed. Let's examine this request in the event log. Notice the last request has a violation rating of 3. The PHP file type was configured with an expected query string length limit of 800 bytes, but this request was 1,525 bytes. It violated the query string length attribute for the PHP file type, however it wasn't blocked. Do you know why? We'll now access the web application again, and use a utility called Burp Suite. Burp Suite enables us to examine and modify our request before sending it to the web server. After accessing this page, we can view the request in Burp Suite. We'll modify the page by adding several additional very long HTTP headers. Clicking forward sends this request to the web server. The request with the extremely long HTTP request length was allowed. We'll reload the event log to view the request. Again, this request has a violation rating of 3. The PHP file type was configured for an expected HTTP request length of 3,500 bytes, but this request was 4,036 bytes. It violated the request length attribute for the PHP file type. However, it also wasn't blocked. Do you know why? Let's return to the allowed file types page. We'll select to enforce the PHP file type. Note that this file type entity is no longer in staging, which means that BIG-IP Advanced WAF will now enforce its length limit values. We'll now re-access the web application to attempt these malicious requests again. The request with the extremely long HTTP request length is now blocked. The request with the extremely long query string length is also now blocked. In the event log, you can see that the requests for both index.php and setup.php were blocked by the BIG-IP Advanced WAF security policy. Although both requests were for a valid file type, PHP, they both violated one of the length attributes of the PHP file type. While the entity was still in staging, the illegal requests were still allowed, even though the security policy was in blocking mode. Only until we enforced the file type entity did BIG-IP Advanced WAF block requests that violated its length attributes. Next, we'll look at enforcing parameters. We'll start by accessing the web application and attempting a malicious request. After submitting this value, notice that the URL shows the parameter name, which is name, and the parameter value, which is AWAF. We'll now insert several additional, illegal, parameter names and values. And then resubmit the request. Currently, malicious users can easily exploit the web application by inserting illegal parameters with dangerous values. To protect the web application, we will first return to the security policy settings. And then re-enable automatic learning. We'll then return to the learning and blocking settings page. We'll expand parameters and change the Learn New Parameters option to Always. We'll then select the Learn, Alarm, and Block checkboxes for all parameter violations. And finally, we'll select this option, which ensures that BIG-IP Advanced WAF will configure each parameter according to the data input by users. We'll now build a list of allowed parameters, and then examine enforcement of the parameter list. We're going to simulate numerous requests to the web application using an I macro in Firefox. We're using these requests so that the policy builder can learn about the different parameters used in this web application. Next, we'll examine the parameter list page. Several parameters have been added to the allowed parameters list. The different parameters are also called entities in BIG-IP Advanced WAF. We'll delete the wildcard entry to prevent the security policy from allowing any parameters that are not on this list. We'll now return to the Learning and Blocking Settings page and stop the learning of new parameters. And then disabling learning, which will prevent BIG-IP Advanced WAF from learning any new parameters. We'll now use the web application and attempt to insert the illegal parameter names and values we used earlier. This request is now blocked by BIG-IP Advanced WAF. Let's examine this blocked request in the event log. The request was blocked because it contained 4 illegal parameters. The log entry displays each illegal parameter name and the submitted value. Notice in the decoded request section, BIG-IP Advanced WAF highlights the illegal parameters and their values. Next, we'll exploit parameter entities that are not yet enforced. Let's open the parameters list page and select the name parameter. This is the parameter we've been using in the web application. First, we'll change the parameter value type to user input value. Notice this enables several other configurable options. Let's change the maximum length value to 20. Next, we'll open the value meta characters page. This page enables us to specify all allowed and disallowed keyboard characters that can be input into this parameter. Notice that several keyboard characters are already disallowed for this parameter by default. We'll select the exclamation point, the hashtag, and the open and close parenthesis. For each of these 4 keyboard characters, we'll select disallow. Finally, we'll open the attack signatures page. Notice that BIG-IP Advanced WAF is already protecting this parameter from nearly 1,000 attack signatures. Let's update this parameter and then apply the policy. In the web application, we'll submit a long text string into the field. This request is allowed. Let's examine the request in the event log. This request, with a violation rating of 3, had an illegal parameter length value. The name parameter was configured with a maximum length of 20 characters, but this request was for 136 characters, but it wasn't blocked. We'll now submit an entry with several illegal keyboard characters into the field. This request is also allowed. In the event log, we can see this request contained 4 illegal meta characters. However, it also wasn't blocked. Next, we'll submit a couple of entries with attack signature strings into the field. Both cross-site script requests were allowed. In the event log, you can see that both requests are flagged with attack signature violations. However, neither malicious request was blocked. Do you know why these 4 illegal requests were not blocked? Let's return to the parameters list page. We'll now select to enforce the name parameter. Note that this parameter entity is no longer in staging, which means that BIG-IP Advanced WAF will now enforce its attribute settings, such as maximum length, disallowed meta characters, and attack signatures. We'll now re-access the web application and attempt these malicious requests again. The request with the long text string is now blocked. The request with the disallowed keyboard characters is also now blocked. Both cross-site scripting attempts are also now blocked by the BIG-IP Advanced WAF security policy. In the event log, you can see that multiple requests for the vulnerabilities/XSS URL were blocked. Although all 4 requests were for a valid parameter, the name parameter, they all violated one of the parameter's attributes: the maximum length, the allowed meta characters, and signature violations. While the parameter entity was still in staging, the illegal requests were still allowed, even though the security policy was in blocking mode. Only until we enforced the parameter entity did BIG-IP Advanced WAF block requests that violated its attributes. Thank you for watching this exercise on how entity enforcement affects whether the F5 BIG-IP Advanced WAF security policy allows, or blocks, illegal requests. We encourage you to watch additional AWAF demos and exercises, and for more details on how Advanced WAF can protect your web applications, contact your F5 Networks Sales Account Manager. For questions or comments about this video, contact Chris manually at the email address at the bottom of the page.